So to get a license, we need to appear for an exam. That exam consists of 25 questions. 25 questions, 1 hour, 100 marks. 25 questions, 60 minutes and 100 marks. So the 25 questions consists of various area. So broadly we categorize into electrical, electronics, project management, PMP, and computer communication general topic. Broadly categorized into 4 parts. And out of 4 parts, we take first 3 parts is a core part and the 4th one is a management topic. And in general, we have here at least 7 to 8 questions from the electrical. In general, we say 8 questions from the electrical, 8 questions from the electronics, 4 questions from the computer communication general topic, and 5 questions from the PMP. It is general information. So person to person is may increase or decrease. So statistically, we have these parameters. So based on the area, subject wise. And we have 25 questions. The questions classified based on this area. At the same time, in our exam, we have a theoretical questions and problem questions. So in general, 50% theoretical questions, 50% problem questions. And the problem means not what we did in our college days. It's not a very lengthy problems. So as I told, we have 60 minutes, 25 questions. That means approximately 2.5 minutes per question. So we need to answer the problem within 2.5 minutes or the maximum 3 minutes. So that type of problem only we may have. We didn't have a very lengthy problems like 8 marks, 10 marks, like what we did in our college days. So here we have 25 questions. So all the questions is a multiple choice questions. The computer based multiple choice questions. So in general, we have 4 options. Yes, sir. So in general, mostly we have a multiple choice questions and each of questions having 4 options. So rarely we may have a 5 options. Rarely we may have a true or false. Mostly we have a multiple choice questions. And in this exam, we have no negative marks till now. So you can able to attend all the 25 questions. So there is no negative marks. And as I told, we have some problem questions also there. So to solve the problem, we need to use the calculator. So before going to that, the problem means, so mostly we have a problem questions, we may have a arithmetic problem. For example, in our question, the given data, we have a power and we have a voltage, we need to find the current, which means just we need to divide the 2 numbers. So simple arithmetic problems we may have. Sometimes we have a power, voltage, we need current, we need to find the power factor, or we need to find the phase angle, which means we need to use the cos theta or sin theta. So we have a trigonometrical functions. So in our problem, we may have a arithmetical problem or trigonometrical problems. Or suppose if you are belongs to communications electronics engineer, so you may calculate the gain, the gain in terms of decibel. So decibel means we use the logarithm functions. So a problem may have using log functions. Sometimes we use the function e to the power of x, exponential functions. So in general, we have an arithmetical problem or trigonometrical functions or logarithm functions, exponential form or x to the power of y. So these type of functions, we have a problems. None of the problem they need to ask that. But to solve this type of problem, we need to use the calculator. But in our exam, they didn't allow to take the scientific calculator. And usually we are using the solve the problem using the mobile phone. They didn't allow to take the mobile phone inside the exam hall. But at the same time, we may use the system calculator because, as I told, it's a computer-based multiple choice question. So we are taking the exam sitting in front of the system. So we are used to allow the system. So in the system, we have a desktop calculator. We may use the desktop calculators. So for exam point of view, you need to prepare or you need to hands-off training in the system calculator. So in the system calculator, how to use the scientific calculations Like this, so let me discuss during the problem we are using. But usually in our office, we are using the calculator mostly for the arithmetic calculations. Usually we multiply or divide, usually in our office. And so as I told, we have some problems. So to problems means we need a rough sheet to do some calculations. Again, they will provide the rough paper. They didn't allow to take anything inside the hall. So in general, for this exam, we need to carry two things kept inside the hall. Number one, Qatar ID. Number two, pen. These two things are only they are allowed to take inside the hall. Rest of all the things we keep outside. In the earlier, that is 2 years before, in addition with the QID, we need to carry the credit card and debit card to get the license, because earlier days they give the printout in the exam hall itself. So nowadays we can able to take in the printout. So that is no need to take the debit card or credit card in the exam hall. The only QID and the pen. This is enough to get inside the hall. And here the important limitations for getting the license. Here we have limited only 2 chances. We need to have n number of chances. Only we have 2 chances, or we say 2 attempts, and we have one more information. We have supplementary chances. So usually what we say, the supplementary chances, just like in our colleges, we did an exam. Unfortunately, we didn't get the good marks. What we do, we request the professor for the re-exam or retest. So if we request, the professor give the schedule. If not request, they didn't give a schedule. So the supplementary exam is, if a request for the MMU office, they will give the chances. And we need to request within a month. Within the month, we need to request, then only they give the supplementary chances. Else, we didn't have these supplementary chances. So in general, we may say 4 chances, but strictly speaking, it's not a 4 chances, it's only 2 chances. If we forget the supplementary chances, only we have 2. Yes.
So 50% minimum, but so it means 30%.
Yes. Now, so to get the license, we need to appear for the 25 questions, 60 minutes. But the pass mark, 50%. That is, out of 25, we need to get 12.5. So rounded to be 13 right answers. So usually what we say, instead of 13, we say 14 bar, because you are working in the construction field. So always you put some contingency. So that's why instead of 13 questions, we say 14 questions. So out of 25, we need to get the 14 right answers, we will get the license. So strictly speaking, 13 is enough. So we put 1 for the contingency. Because we engineers, we are working in the construction field. So always you put some contingencies. And in general, most of the result will be published immediately. Within an hour, you can be able to find in the Hukumi account. And so this is to get the license. But most of the people, we need a license with grade. The grade is purely depends upon the experience, not based on the mark. Out of 25, suppose if you think that 25 out of, if I get a 20 questions, we say A grade like this, not like this. So to get the license, we need to appear for the exam and we need to get 14 right answers. To get your grade, you need to submit your, along the document, you need to submit your experience certificate. So in general, less than 5 years, they consider as a trainee. Less than 5 to 7 years, they consider as a C grade. 7 to 10, B grade, and above 8, above 10, they consider as a A grade. So, and again, the grade is based on their this. So what we say, for example, we say, I have a 9 years, 9 months. So usually what we say, 10 years experience. But they didn't, they do not round up, round down. 9.9, we say the round up means we put a 10. So round down becomes 9 in the Excel sheet. So always the experience they consider as a round down functions. So 9 years, 9 months, they consider as a 9 years, not 9 months. Okay. So this is the exam pattern for getting the licenses. So again, and So to get the license, to appear for this exam, they have some specific syllabus. Again, this is the syllabus, but it's not provided by the MMUP. So this is the syllabus. We frame the syllabuses. We frame the syllabus based on the question papers. So because last 5 to 10 years, we are collecting the n number of questions. So based on the questions, we frame the syllabus. So usually in our colleges, what we do before the semester exam, we collect the previous question papers, last 2 years or 3 years question papers. Based on the question papers, we find our own, we set a own question paper. We forget about the syllabus. We forget about the book. We take the 5 years question paper and we frame the important question for the first unit. We have 3 questions. Second unit, we have 2 questions. By this way, we frame our own question paper and we prepare for that. So similarly, we frame the syllabus based on the question paper. Again, this is the today's syllabus. This syllabus based on the yesterday question paper. And you have an exam on tomorrow. So that way, it not linked the things. So the syllabus is time to time, it changes. Again, 3 years before, they didn't ask any question from the computer communication related topics. So nowadays, they ask these questions. So nowadays, they didn't ask any question from the DC machines. So that's why what we do, we remove the DC machine topic, we include the computer communication topics. So later on, again, after 3 months, again, we may change, include one topic or remove some topic based on the yesterday question papers. So right now, we discuss these topics. And here we have 10 classes. Out of 10 classes, each class is approximately having 3 hours, 7 to 10. So out of 10 classes, 8 classes for the core subject and 2 classes for the project management, PMP class topics. So out of 8 classes, so we have a DC fundamental. The first class we discussed about the DC fundamental. In the DC fundamental, so usually we discuss about the Ohm's law, Kirchhoff's law, Kirchhoff's voltage law, current law, and we have series circuit, parallel circuits, and we have theorems. And so we study in different universities, different curriculum we may study, but here we are limited to Thevenin's theorem, Norton's theorem, superposition theorem, and maximum power theorem. Because so far we have a question from these theorems only. That's why in this class we discuss this theorem. Suppose tomorrow we have a new questions related to the reciprocal theorem, means let me discuss that theorem in the day after class. So in general, we have 8 classes. In general, each topic you may expect 2 or 3 questions from each classes. So 8 into 2, approximately 16 questions. And the second class we discussed about the AC fundamental. In the AC fundamental, usually we say 230 voltage, 240, 450, 11 kV. All these numbers is related to the RMS quantities. But in the DC, simply we say voltage. But if you come to the AC, we have a RMS voltage, average voltage, peak voltage. So that's why we have a different notations are that we need to discuss about the different voltages. And we have a frequency, time. And if we know the voltage, then we discuss about the various passive component, in general resistance, inductance, capacitance. And how these resistance, inductance, capacitance behave if you apply the DC voltage, if you apply the AC voltage. If you apply the AC voltage, then we discuss about the power factor. Then we discuss about some little problems related to the basic AC fundamentals. Then we have a resonant circuit is related to the communications. The resonant, the word resonant belongs to the electronics and communications. So we have questions from the resonant circuits also. So RLC, resonant circuit. So in the resonant circuit, just we discuss about the 4 to 5 different formulas. Wow. Resonant frequency formula, bandwidth formula, and quality factor. And again in our exam, they didn't ask any theory questions. There is no need to by heart the theorem. There is no need to by heart the laws. And RLC transient circuits. These are the topics we discussed in the second class. And the third one, we have as electronics fundamentals. So in general, nowadays, we have a question from the diode, Zener diode, transistors, operation amplifiers. So that's why, because in our colleges you study the JFET, MOSFET, power electronic devices, so many devices you may study. But here we discuss only diode, Zener diode, transistor, operation amplifier, because we have a question from these topics. And from these devices, we have some circuits and applications, all the things we discuss in the third class. On the fourth and fifth is related to the electrical machines. So electrical machines broadly categorized into three different categories. One is a transformer, DC machines, AC machines. So in the fourth class, we discussed about the transformers. So everyone having at least one or two questions from the transformers. And as I told, DC machines, nowadays they didn't ask any questions in the DC machines. So we just 10 to 15 minutes discuss about the DC machines. Then we switch over to the AC machines. That is, we discuss in the fifth class, we discuss about the AC machines. Again, in the AC machines, again, broadly categories into three categories: alternator, induction motor, synchronous motor. So mostly everyone having at least one question from the alternator, synchronous machine, and induction machines. And the sixth class, we have a power systems, control systems, measurements. So again, the class 1 to 5, we discuss in detail about the topic wise. But the sixth class, 7th and 8th, instead of topic wise, we discuss the question and answers. Because power systems, control systems is a wide area, but we have a limited questions. So instead of discussing topic wise, it takes more time. So that's why we collected so many questions. So in the classroom, we discuss the question answers. Question answers related to the topics also, not only the question and answers. And the sixth class, okay, in the 7th class, we have oscillators, logic circuits, timer circuit, computer communication, all related questions we have discussed in the last classes. Okay, so these are the topics we discussed throughout these 8 classes. So any queries about the exam patterns and general informations? Yes.
There is a possibility that they will repeat the questions from the previous exams.
Yes. Because again, the question is generated, it's a multiple choice computer based question, which means the questions are available in the server. That means it's a finite number of questions are available in that. It's generated by systems. So in the server, they give n number of questions.
So they will not change, for example, the givens. For example.
Yes, again. So again, nowadays, what they say that first question, we have a limited or the finite number of questions are available in the server. That questions only nowadays they generated. At the same time, so earlier they give, for example, we have one question, we need to find the resistance, the given data, power 100 watts, voltage 200 voltage, find the resistance. This is the question they asked that. So nowadays they change the question, the same power 100 watts, instead of voltage 200, they change the word 220. The concept remains same. Sometimes they change the numbers, very rarely. At the same time, if I by got the numbers, by got the answers, definitely sometimes you may fail in that, fail to answer the questions because sometimes they change the numbers. So that's why in the classroom, you need to know the formulas and how to solve the problems. But in general, mostly 80 to 90%, they didn't change the numbers, especially the 1 and 1, 2, 3. Here they change the numbers. For example, some theory questions. For example, what is the application of the Zener diode? It's a voltage regulator. It remains constant. And sometimes if you go to the general topic or in the power system, control systems, most of the questions, they didn't change the numbers. So in the classroom, I inform that these are the questions. Nowadays, they change the numbers like this. But again, it's a finite number of questions available in the server. So we have n number of questions we collected from the persons. So we have in the mock exam, in the LMS, because you have more than 400 to 500 questions are there. So that questions mostly we have a review from those are appear in the exam. They say that more than 15 to 16 questions they may have that from this question banks. But at the same time, always we need to believe not only based on this, with the help of the Allah only we need to get the license. So it is, we need to prepare well. At the same time, we need to get the God's grace also. Don't believe that, don't think that, okay, we attend the classes, we discuss the 300 questions, I got all the 300 answers, so definitely we need to get the license. Don't believe like that. So nowadays they change the numbers, they change some things. Okay. Hello, sir. Any queries?
So the mock test is from the previous exam, right?
Yes. So in the mock exam, we have a more than 10 to 15 mock exams are there. So all the questions are asked in that exam. That is, the questions are solved by engineers.
So it is possible that
That is possible.
question will.
Yes. So at the same time, what I told, in your college days, before going to the semester exam, you collect the previous question papers. Suppose you collected 2 number of question paper, the possibilities is limited. Suppose you collect 10 question paper, the possibilities are high. So by this way, we collected more questions. That's why there is a possibility, high possibilities are there. At the same time, I say high possibilities, don't take the granted. So you prepare one, you study the particular questions alone is enough to get the license. Don't think like that. Yes, sir. Tell me, sir. Hello.
Hello, sir.
Yes,
Yeah. Listening, sir.
Okay. So before going to the class, sir, again, advance congratulations to everyone to get your license. Okay. Today we discussed about the DC fundamentals. So today's class we discussed about the Ohm's law, Kirchhoff's law, series parallel circuit, temperature coefficients, and various theorems. So in general, we may have expect 2 or 3 questions from these topics. At the same time, this is the basic fundamental. If you know the basic concept, you the same type of questions they ask in that different area. For example, say simple example, if we know the frequency, we can able to find F is equal to 1 by T, irrespective of the place. F is equal to 1 by T. So this formula we discussed in the second class, AC fundamental. But at the same time, in the classroom, frequency 50 Hz, what the time F is equal, T is equal to 1 by 50, you calculate some numbers. But they asked one question in the multivibrator. In the multivibrator, they say the clock frequency, they give the clock frequency, we need to calculate the time. But the formula is not related to already the same formula what we discussed in the AC fundamental. So that's why in the DC fundamental, AC fundamental, electronics fundamental, if you know these 3 fundamentals, we may answer in some other areas. Okay. So Ohm's law. So in college days, we studied in constant temperature. At constant temperature, the current is directly proportional to the applied voltage. By this way, we got the law. But in our exam, they didn't ask the definitions. Write that define Ohm's law. We need to write a 2 line. That type of question, they never ask that. So here we need to understand the concepts. So first point, the Ohm's law at constant temperature. So we need to remember the term. At constant temperature only, the Ohm's law will obey. Number 1. Number 2, we need to remember the second term, current is directly proportional to voltage. In the mathematics, we say Y is directly to X. And or we may say A is equal to B, B is equal to A. So we may say in the mathematics it is okay. But if you come to the law, it is not true. So that means current is directly voltage, it is a current. But at the same time, voltage is directly proportional to current is wrong. So see the diagram, that way we can able to understand. So this is the green color current. The current is moving from one place to another place. Assume that I am an electron, I am standing here. So I need to move from this place to this place. So the movement always happen. Sometimes we need to give some forces. So externally someone push me, then only the electrons move from one place to another place. So the movement of electron depends upon the someone push me, depends upon the force. So the force is 0 means the current is 0. That is, the voltage is 0 means current is 0. So that's why current is directly, the movement of electron depends upon the force. So this is true, but the vice versa, it is not true. So here I is directly proportional to V. Okay. Now, so again, I am an electron, someone pushed me, I am moving from one place to here. The time taken, for example, say 100 meters, I take 10 seconds. They give some forces. Again, now I am here, they receive the same forces, but the movement is delayed because the movement is not depends upon the force, depends upon the floor. The floor is smooth floor means I can able to move fast. The floor is rugged one, or is not smooth one, the movement is different. So similarly here we say I is directly inversely proportional to resistance. So we have two informations. Put together, we say I is equal to V by R. So from this, what we understand, current is directly proportional to the voltage and current is inversely proportional to the resistance. And so mathematically, I is equal to V by R. So now I rewrite the equation like this. I is equal to 1 by R into V. So now in the mathematics, we study Y is equal to mx. So see here, these two equations are similar. So here Y, so in the mathematics, we say Y, in the electrical, we say current. In the mathematics, we say X, in the electrical, we say voltage. In the mathematics, we say M, slope, and here 1 by R. So here from this, Y is equal to M by mx, this is the line equation for the line. So we may draw the line. So this is X, this is Y. So we draw the line. So Y is equal to mx. So we draw a line. Correct? So now again, so instead of X, we put a voltage. Instead of Y, we put a current. And the graph is like this. So from this, what we understand, if the voltage increases, current also increases, but it's a linearly increases. That information we need to remember. From the Ohm's law, it's a linearly increases. And the slope is depends upon the R. So here we draw the graph voltage versus current. Similarly, we can able to draw the graph resistance versus current. So we need to draw the graph resistance versus current, that is I is equal to 1 by R. I is equal to 1 by R. It is nothing but Y is equal to 1 by X. So that's why the graph is just like 1 by X graph. So we need to remember again. Here voltage, here current. So these two graphs is obey the Ohm's law. Okay. Now, that right. Yes. No, the angle is depends upon the resistance. That is we call as a slope. In the mathematics, we draw the line. Here what we understand from this graph, we understand it says linearly increases. The straight line is maybe like this or this one or this one, depends upon the resistance value. And compare these two graphs. This also is a linear, this also linear. Which one is the right? So usually at the instant, usually we see in this area. So it is also a straight line. It is also a straight line. But as per the Ohm's law, the current is increases depends upon the x. So or in the mathematics, what we say in the x-axis, always we put the dependent. Here it's an independent variable. It is a dependent variable. In the x-axis, always we put the independent variable. For example, easy to understand. So we take a stick and someone hit my hand. Okay. So suppose we have a 10 times of stick, I have more pain. If you have only one strike, we have less pain. So the number of strike is a independent variable. Pain is a dependent variable. So here we have a pain. Here we have a number of strikes. So pain always depends upon the number of strikes. So always the current is a dependent variable. So if they have a zero voltage, we have zero current. So that's why. So in our exam, we have some graphical questions also there. If you have a question related to the graph, means first thing you check the x-axis and y-axis. In the x-axis, always it's an independent variable. In the y-axis, always dependent variable. And the current, the unit of the current is ampere, everyone knows. But this question also asked in the exam. If you are lucky, you may have this question. And what is the unit for the voltage? Volts. And unit for the resistance? Ohm. So now we go for the resistance and resistivity. So in this column, we have a resistance and resistivity. Here, conductor and conductivity. First, we start with the resistance and resistivity. So resistance. Here, resistance R is equal to rho L by A. So this formula is applicable for the constant temperature. If the temperature changes, the resistance value changes. So here the formula R is equal to rho L by A for the room temperature or constant temperatures only. So here R stands for resistance, L stands for length. So length, A stands for cross-sectional area. So in general, the unit for the resistance ohm, length in terms of meter, but in our exam, sometimes the given data not in terms of meter, in terms of kilometer and other things. So we need to convert the kilometer into meter. And A, cross-sectional area. So unit is meter square, but in your exam, the given data in terms of centimeter square or millimeter square. We need to convert that. What is the formula for the area? What is the formula for the area? Okay. Here, the formula for the area depends upon the question. Suppose the conductor is a cylindrical conductor, means we use the formula pi r squared. Suppose it's a bus bar, they use the square bus bar, rectangular bus bar, means we use the length and breadth. These are simple information, just keep in the mind. And rho stands for resistivity. Rho, cross-sectional area, length. Okay. Rho stands for nature of the material, or we call as a resistivity, or sometimes we use the word specific resistance. So sometimes in your college, you may use the word resistivity or specific resistance. Both are same. So unit for the length, it is meter. Unit of area, meter square. Resistance, ohm. So from this, because we know these three things, so we didn't know the unit for the resistivity, because in general, in the daily life, we didn't use these terms. So mathematically, just you calculated, we get the answers. Rho, which is equal to ohm meter square divided by meter. So we cancel ohm meter. By this way, in the rough paper, you may write that, or you by got the answers. So this question asked in that exam. What is the unit for the resistivity? Unit for the resistivity is ohm meter. So nature of the material means is maybe a copper, silver, whatever thing. Every metal having its own specific resistance or resistivity. That's why we use the word rho, nature of the material. So the rho value for every metal, we have different values. So here we have a resistance and resistivity. So in the other hand, we have a conductance and conductivity. So what is the conductance? Conductance denoted by G. Resistance denoted by R. So we need to call it the resistance conductance. So conductance G, which is equal to 1 by R. That is reciprocal of the resistance, we call as a conductance. What is the unit for the resistance? Ohm. Unit for the resistance is ohm. What is the unit for the conductance? Reciprocal of the resistance. So OHM. This is the unit for the resistance. Here the unit is MHO. So reciprocal OHM becomes MHO. And this is the symbol and becomes like this. So the unit of the conductance is mho, denoted by this symbol. And we have one more unit also there. The unit for the conductance is Siemens. So this question also asked in that exam. Unit for the conductance, mho or Siemens. So G is equal to 1 by R. What the we know the formula R is equal to rho L by A. So what is the G is equal to 1 by R. So which is equal to 1 divided by rho L by A. So here we write that. So R is equal to rho L by A. So G is equal to, we put that reciprocal. So here we use the term sigma. So rho stands for resistivity, sigma stands for conductivity. Or we may say it's a specific resistance, it's a specific conductance. So the unit is ohm meter. That is rho. And what is the rho? Sigma is equal to 1 by rho. Because conductance which is equal to 1 by resistance. So conductivity which is equal to 1 by resistivity. So here ohm meter. So here G, R is equal to ohm. So G is equal to mho. So here ohm becomes mho and meter is in the multiplication, here reciprocal, so divided by meter. So this is the unit for the conductivity. So there is no need to by heart the formula. So just we know, remember this formula is enough. If we know this formula, we can be able to write this one. If we know this one, we can be able to write the formula, this one. The only thing we need to know, G is equal to 1 by R. sigma is equal to 1 by resistivity. That's all. Okay. Yes. Or we may use this formula. So conductance, we have 2 units, either Siemens or mho. Now we need to calculate the resistance if the temperature varies. So this is the formula if the temperature changes. So here R T is equal to R naught 1 plus alpha naught T. So this is the formula to find the resistance for variable temperature. For any temperature, not variable temperature, for any temperature. R is equal to rho L by A for the room temperature. So ideal condition, we say 40 degrees Celsius. Suppose we need to calculate assume that the real-time applications. So we are procuring a new induction motor in the Rastavan. We procure the induction motor in the December month. In the December month, the temperature approximately 20 degrees Celsius. So we procure this induction motor. So we have we calculate some efficiency. The same induction motor, we calculate the efficiency in the June month. The temperature is 50 degrees Celsius. So the same motor, but we have 2 different temperatures. The same motor, the inside we have the same number of turns. We have a winding. The winding is made up of copper, same n number of turns. We are applying the same 440 voltage. So all the things remain same. Only variable thing is a resistance. So the depends upon the ambient temperature, atmospheric temperature changes. So the resistance value changes. So at the time also we use this formula. Is the one example. In other example, suppose in the boiler, if we are working in the chemical plant. So we need to measure the temperature in the boiler. So how to measure the temperature? Usually we are using the thermometer at the maximum 100 degree or 120 degree. We are using the thermometer. Suppose we need to measure the 1000 degrees Celsius. How to measure the 1000 degrees Celsius? By using this formula. Because we take assume that we have a resistance. We calculate the resistance value at 40 degree, say is 10 ohm. If it is inserted in the boiler, because due to the temperature, the resistance value changes. Because the metal changes. So now we need to calculate the voltage and current. We have some methods are there. By this way, we can be able to calculate the resistance inside the boiler. So this formula which is used in this area. So easy to remember. I hope you may hear this word. RTD stands for resistance temperature detector. This is the terminology which is used in the boilers to measure the temperatures. So the RTD working based on these formulas. Let me discuss in detail in later classes. So RT is equal to R naught 1 plus alpha naught into T. First think R naught. R naught stands for resistance at 0 degrees Celsius. So RT stands for resistance at T degree. Suppose we need to calculate 50 degree or we need to calculate 1000 degree, whatever thing. So the RT stands for resistance at T degree Celsius. So the T is also here. Alpha naught is a temperature coefficient. This is the predefined value, like R naught. So here, this R naught and alpha naught is a predefined value for every metal. You take a silver, the silver we have the data sheet for the room temperature. This is the resistance value at 0 degree. At the same time, alpha and temperature coefficient. So this R naught and alpha naught is a predefined value, or predefined value, which means it's a constant. So we need to rewrite this equation like this. R naught is equal to, sorry, RT is equal to R naught plus R naught alpha naught T. Okay. So RT, we assume that mathematically we say Y. R naught alpha is a constant, that's why you put a M. So T is a temperature, you put a X. And R naught is also constant, so we put a C. So this equation is just like Y is equal to Mx plus C. So we can able to draw the graph. Okay. So from this, what we understand, RT is depends upon the RT is equal to R naught. We have 1, 2, 3, 4 variables are there. Out of 4 variables, R naught alpha is a constant. So which means we have 2 variables. One is RT, another is a T. So the RT is depends upon the T value. The temperature increases, RT is increases. So now we can able to draw the graph like this. So in the x-axis, we put a T. In the y-axis, we put a RT. Okay. T is an independent variable, RT is a dependent variable. So in this equation, x is equal to 0. What is the value? Y is equal to C. Or put T is equal to 0. What is the value? RT is equal to R naught. So T is equal to 0 degree. We have final number. So the graph is like this. Okay. At T degrees, T is equal to 0. What is the value of R naught? R naught is equal to resistance at 0 degrees Celsius. So T is equal to 0 means this is the point. At T is equal to 0, we have some resistance. So any metal having one finite resistance value at 0 degrees Celsius. So that's why we put, instead of origin, we put here. Okay. Now the temperature increases. What will happen? Mathematically, it's increasing like this. Okay. See here. So in the temperature, in the y-axis, we have resistance. So take the blue color. The temperature increases is linearly increasing. Okay. The temperature increases. So from this formula, what we understand, we take 2 different pens. So we have two metals. So assume that it's a conductor, it's an insulator. We didn't know it's a conductor, it's an insulator. We did an experiment by using this formula. We did an experiment, and one experiment, the blue color is increasing, and the red color is decreasing. So now we understand what we say, that the blue color is a conductor. The conductor, by using this formula, the temperature increases, the resistance is increasing, which means the conductor having positive temperature coefficient. So in the mathematics, we say like this. So the conductor always having a positive temperature coefficient. Insulator and semiconductor having negative temperature coefficient. So in our exam, we may have some questions. The conductor having positive temperature coefficient, negative temperature coefficient. By using this formula, we may have this question. So here from this slide, what do you understand? Conductor having positive temperature coefficient and insulator semiconductor having negative temperature coefficient. Or in front of us, we have a different metals are there. How we identify it is a conductor? We need to conduct that experiment by using this equation. Then if we have a positive temperature coefficient, we say this group of element are called as a conductor. Yes, I told that RTD stands for resistant temperature detector. So sometimes they ask these definitions, and we have one problem that we discuss the problem related to the instrument, that is measurements. So in the measurement topic, we discuss the problem related to the temperature RTD. Okay. So from Ohm's law, V is equal to IR. Just everyone familiar with this formula. At the same time, we need to remember the formula, because in our exam hall, we have 25 questions, 60 minutes, each question having 3 minutes, approximately 2.5 or 3 minutes. So that's why some of the formula, basic formula, we need to memorize it. Some of the formula that is no need to memorize. In the exam hall itself, we need to write that up. So it's a basic formula. So that's why you need to memorize the formulas. So P is equal to voltage into current, and Ohm's law, I is equal to V by R. So that's why what we say, instead of I, we put a V by R, which is equal to V into V by R. We say V square by R. So that's why we are having this formula. So in our exam, how the formula is derived? In our exam, they didn't ask that. If we know the formula, we can be able to save the time. That's all. And we have one or two questions related to the energy. That's why we say energy G is equal to power into time taken. The time taken in terms of seconds, T in terms of seconds. So here we need to remember about some basic, because we engineers, but more than very long back we studied that. That's why everyone knows kilo 10 power 3, mega 10 power 6, because we are using these two terms in our daily life. As an electrical engineer or if you are electronics engineer, you use the word megahertz. These terms you may be familiar with it. That's why we need to remember these things. Milli 10 power minus 3, micro 10 power minus 6, nano 10 power minus 9, pico 10 power minus 12, femto 10 power minus 15. 10 power 3 kilo, 10 power 6 mega. So mostly we have a question from these areas only. Just for information, we need to remember 1 or 2 times. So again, in the electrical questions, we may have a kilowatts, kilo kVA, MVA like this. And we come to the electronics or in the inductor capacitors, we use the word millihenry or microfarad. So these are the terms. Very rarely we may have a picofarad. So usually we have a femto, nano, we say very rarely. But we need to remember these numbers. And at the same time, we need to familiar how to use the calculator. 10 power minus 6, how to use the calculator, then only we can be able to save the time and we can be able to solve the problems also. So Kirchhoff's law. Hello, sir, is okay? Hello?
Hello, sir. Yeah.
Okay.
Yeah.
Now we discuss about the Kirchhoff's laws. So Kirchhoff's, we have two laws are there, Kirchhoff's voltage law and current law. And again, as I told, in our exam, they didn't ask the definitions, just we need to remember the concepts. So here, usually, current law means important thing, we need to remember node. In your circuit, if you see the node point, then we can be able to apply the Kirchhoff's voltage law. Sorry, Kirchhoff's current law. And if you have a closed circuit, we can be able to apply the Kirchhoff's voltage law. So, in our home country, not in Qatar, we didn't see that. In our home country, nearer to our house, we have a poles are there. In the poles, every houses we are taking the power from the service main. We have small wires connected from the pole. So my house, we are laying 2 wires. By this way, all the houses they put a tapping. So usually we use the word tapping. So from the one conductor, we put a tapping from 2 wires for my house, another 2 wires for other houses. So the tapping, in other words, we call it a node point, because all the different houses we have a different current rating. Or so nowadays we are using the multiple phones. Everyone having more than 1 or 2 phones, and we have a multiple charger. In the multiple charger, we are using the Kirchhoff's node, the current law, because so usually we have here. This is for the Apple phone. This is for the Samsung. By this way, we have multiple charger, and we have small square boxes. So here we have a phase neutral. So this is the multiple charger is the example for the Kirchhoff's current law. Or if you go to the SLD, in the SLD we have a bus bar, and we have a from SMDB to we have divided into 3 different dBs. So here we are using the Kirchhoff's current laws. But again, here in exam point of view, we forgot about the SMDB, SLD, sir. So they use a small problem. We need to solve this problem. That's all. So here, as I told, in your circuit, if you see the junction point or if you see the node point, we need to apply the Kirchhoff's current law. So here, so simply we say so simply Kirchhoff's current law at node point, current enters, which is equal to current leaving. That's all. Or we may say I in minus, depends upon the problem. That's all. Okay. So by this way, we write this equation. The red colors are leaving from the node and black colors are towards the node. That's why we use these things. So in the other hand, so here we have 2 resistance are there, resistance R1, R2. And here you apply the voltage V. So every resistance, if you have a resistance, if you apply the voltage, what will happen? It takes some current. So the resistance R1 take the current I1, resistance R2 take the current I2. The resistance R1 take the current I1. So by using the Ohm's law, because just now we studied Ohm's law, by using the Ohm's law, I is equal to V by R or V is equal to I into R. So here we say V1. V1 which is equal to I into R1. So here V2 which is equal to I to R2. This is by using the Ohm's law. Now we come to the Kirchhoff's voltage law. So the circuit is closed one. The circuit is closed, we can be able to apply the Kirchhoff's current law, Kirchhoff's voltage law. So the entire circuit I divided into two parts, above the blue color and below the blue color. Below the blue color, we have a voltage source. Above the blue color, we have a resistance. Or we may say, below the part, we call it the active component. Because we have a voltage battery. Above the blue color, we have a resistance. It's called the passive component. So usually the active component, we use the word rise. And the passive component, we use the word drop. So that's why by using the Kirchhoff's voltage law in a closed circuit, voltage rise is equal to voltage drop. In a closed circuit, voltage rise which is equal to voltage drop. What is the voltage rise? V. What is the voltage drop? V1 plus V2. Just for understanding, I say V rise is equal to V drop. But mathematically, we say sum of the voltage rise which is equal to sum of the voltage drop. So in our house, we have in the TV, we have a TV remote. We are using that. The TV remote is nothing but a Kirchhoff's voltage law, because if we remove, we have two batteries are there. We have 1.5 voltage, two cells are there, connected series connections. So put together 3 voltage. So that means we are using that. Or we take the torch light. The torch light also example for the voltage, Kirchhoff's voltage law. If we know the Kirchhoff's voltage law and current law, then we can be able to discuss about the series circuit and parallel circuits. So now we have 3 resistors are connected one by one. So yet now we didn't know about the series circuit. We didn't know about the parallel circuit. What we say, we are connecting one by one series. Resistance are connected. Later on we discuss, okay, this connection we call as a series. So right now we didn't know it's a series connection. So we are arranging the circuit like this, and we apply the voltage, V voltage. So what will happen? The circuit is closed. The circuit closed, what will happen? Current will flow. So where I current is flowing, and the resistance R1 carries I1 current, resistance R2 carry I2 current, resistance R3 carries I3 current. By using the Ohm's law, here we have I current, here I1, I2, I3 current. Let us learn. Right now I didn't know about the series circuit. So circuit is closed, the current will flow. Every resistance having its own current, I say it's I1, I2, I3. Okay. So it's I1 into R1. So that's why the voltage drop across the R1 is V1. Voltage drop R2 is V2, R3 is V3. And now we know Ohm's law and Kirchhoff's voltage law. By Ohm's law, we use the word V1, V2, V3. By using the Kirchhoff's voltage law, we say V is equal to V1 plus V2 plus V3. Okay. Then V is equal to, because sum of the voltage rise which is equal to sum of the drop. So that's why V is equal to V1 plus V2 plus V3. What is the value of V1? I1 into R1 plus I2 into R2 plus I3 into R3. Okay. Now I1, I2, I3. Now we need to apply the Kirchhoff's current law. What is the Kirchhoff's current law? In the node, the current is divided. We take one node point, current entered and current leaving. Assume that it is a one point. And now this point, the current is entered is I, the leaving is also I, not I1. and you take this point. In this point, current entered is I, not I2, because in this circuit there is no node point. So in your circuit, if you have no node point, then we say this circuit is called as a series circuit. So here there is no node point. That's why I1 then we say I1 is equal to I is equal to I1 is equal, because no node point. No node. So now we can able to read the equation I into R1 plus I into R2 like this. Then mathematics, we put a common I. So that's why finally we get this formula. So we need to remember this formula. In a series circuit, so from this what we understand, in the series circuit, there is no node point. If there is no node point, it means the current is same, because I is equal to I1 plus I2 is equal to I3. That's why all the currents are same. What about the voltage? All the voltages are different. Depends upon the resistance value. Irrespective of the resistance, the current is same. You have a different resistance value, we have different voltage drop. If all the resistance are same, all the voltage resistance are having same voltage drop. So in the series circuit, the total resistance R is equal to R1 plus R2 plus R3. So in the other hand, we need to discuss about the parallel circuit. So right now, I didn't know it is a parallel circuit. I connected the circuit like this, and we apply the voltage V volt. I apply the V voltage. So now we need to apply the closed circuit. So closed circuit, we need to apply the Kirchhoff's voltage law or Ohm's whatever thing. In the closed circuit, what will happen? The current will flow. So I current is flowing. And the current is flowing here. And in this point, it's a node point. That's why the current is divided. So divided I1, I2, I3. By this way, is divided because it's a node point. So here the current is divided. That's why we say it is a parallel circuit. Okay. So we say I is equal to I1 plus I2 plus I3. Now we need to calculate the I1. How to find the I1? By using the Ohm's law, I1 which is equal to V1 by R1. V1 by R1, V2 by R2, V3 by R3. And here we have a parallel circuit. So we have this is I1. The blue color is I1. The current flowing by this way. The pink color, the resistance current flow through the I2 is current flowing into the R2 alone. By this way, in all the three different colors, or we say three loops, the same voltage we are using. So that's why we say in the parallel circuit, voltage is same. So in exam point of view, concept wise, here current is same, here voltage is same. Again, in exam point of view, just we need to remember the word current same, voltage same. How it is same in our exam, they didn't ask that. Our objective, our scope of, because again, we take this exam as a project. So in the project, we take the scope of the work. What is the scope of work? To complete the project within the time duration. So we didn't know whether the concept, we understand the concept or not, whatever thing. We need to complete the scope within the time. So the scope is to get the license, not to understand the concept. So it may be just for information. So our objective to clear the. So if you are not able to understand the concept, means just by God. See, series circuit current same, voltage. The parallel circuit voltage is same. If you need it, again, I will explain that. No issues. Okay. So by this way, we are equating and we have the. So this is the total, calculate the total resistance in the series circuit. This is the formula for the parallel circuits. And 1 by R, which is equal to reciprocal, that's why we may write G. Okay. So in exam point of view, irrespective of the concept, we need to remember these points. If we know this point, we can be able to easy to appear then used to take solve the problems easily. So series circuit, current is same. So here the voltage is same. And another important thing, for example, say in a series circuit, 10 ohm, 15 ohm, 25 ohm. For the total resistance value, we need to add these three numbers. Okay. Yeah, three resistance. What is the value? 30. So we say 10 plus 10 plus 10. Suppose we add one more resistance, 10, then we put a 10. So usually we didn't use the calculator 10 plus 10 plus 10. What we say? 4 into 10. Suppose we put one more resistance, 5 into 10. So simply the number 4 refers number of resistance N. The 10 refers the value of the resistance R. So that's why we need to remember this formula. If the resistance are same, the total resistance is equal to N into R. And similarly here, in the other hand, so what is the formula? 1 by R is equal to 1 by R1 plus 1 by R2 up to N resistance. But in addition with in this formula, we need to remember one more formula, especially for the parallel circuit. For the two resistance. For the two resistance, we need to remember one formula. 1 by R is equal to 1 by R1 plus 1 by R2. The formula restricted to only 2. That's why 1 by R is equal to 1 by R1 plus 1 by R2. Then we need to take the LCM. So 1 by R is equal to, we take a LCM like this. Then we get R is equal to R1 . So in addition with this formula, we need to remember this formula also. That is simply I write it. Again in our exam, they didn't ask this entire thing. So simply for two resistance, R is equal to R1, R2 divided by R1 plus R2. Okay. $10 ohm, 10 ohm. For the total resistance value, 1 by R is equal to 1 by 10 plus 1 by 10. So that means fine. Suppose we have one more resistance. So we put 1 by 10. So here instead of 2, we put a 3. So 10 by 3. So from this, what we understand, if having n number of resistance, the total resistance value R by N. R stands for value of the resistance. N stands for number of resistance. What is the answer for this? Because usually due to sometimes curious, we are 10, 10. Don't say 7 and 3 are connected in the same line. So we need to add it. These two resistors are connected in the series circuit. That combination only parallel to the rest of the resistance. Okay. And we will remember this point also. Sometimes by using this concept, we may answer immediately, easily. So we have three resistors are connected in the circuit, 2, 5, 7. The total value is 14. The 14 is greater than the greatest resistance value. So in the series circuit, the total resistance value always greater than the greatest resistance. And in the parallel circuit, the total resistance value always less than the least resistance. By using this concept, we may have some questions. Okay. So all we need to calculate the values, then we need to take that more time. So that's why we will remember these points. So in the PowerPoint, wherever you see that highlighted words, you just need to remember that words. Sometimes it may help to solve the problem easily. By using this series circuit, parallel circuit, we have two rules are there. One is a voltage division rule, another current division rule. Again, if we know this formula, without the formula, we can able to solve the problem. If we know the formula, we can able to solve the problem immediately, or we need to save the time. For example, say here 100 voltage, 10 voltage, 10 ohm, 15. Seven ohm, 3 ohm connected in the series circuit, the applied voltage is 10. We need to calculate the V1. How to find the V1? V1, which is equal to, by using the Ohm's law, V is equal to, I is equal to V by R, or V is equal to I into R. So V1, which is equal to I1 into R1. Okay. How to, what is I1? I1 current flow to the R1. But it's a series circuit. In the series circuit, currents are same. So instead of I1, I use the word I, because total current. I into R1. Instead of I put IT, total current. How to find the total current? Total voltage by total resistance. Total voltage divided by total resistance into R1. VT. What is the total resistance? What is the formula in the series circuit? R1 plus R2 plus R3 up to. So here we say R1 plus R2. This is the into R1. So V1, which is equal to VT divided by R1 plus R2. So here see that one we have there is no need to calculate the current. Without calculating the current, by using the formula, directly we will get it. So that's why this formula we call the current division rule. See here, total voltage 10 divided by sum of the resistance 7 plus 3 into R1. Because we need to calculate the 1, that's why we put R1. Or simply what we say, by using this voltage division rule, the voltage across a particular resistance, which is equal to total voltage divided by sum of the resistance into particular resistance. Or we use the word same resistance. So 1, so that's why 1. Suppose we need to, they ask the V2 means V2, which is equal to 10 divided by 7 plus 3 into same resistance. So this is the same resistance R2. So 3. So that's why the formula you by got like this. Total voltage divided by total resistance into same resistance. So this is the voltage division rule. In the other hand, we have a current division rule. The total current is 10 ampere. We need to calculate, sorry, I1, I2, two resistance are there, 10 ohm, 20 ohm. We need to calculate the I2. How to find the I2? I2, which is equal to, by using the Ohm's law, I2 which is equal to I is equal to V by R. So that is V2 by R2. Which is equal to V2 into 1 by R2. Okay. What is the V2? Voltage across the resistance R2 is nothing but the total voltage, because in the parallel circuit voltage same. So that's why we say total voltage into 1 by R2. How to find the total voltage? Again go to the Ohm's law. V is equal to I into R. That is total current, total resistance into 1 by R2. How to find the total current is available in the given data. RT, total resistance. What is the formula? We have two resistance. So we know the formula. R1 into R2 divided by R1 plus R2 into 1 by R2. This is this value. And mathematically, we may cancel this. So from this, I2, which is equal to total current I divided by sum of the resistance into opposite resistance R1. So IT, total current, that means 10 ampere divided by, again I use the word, in the series circuit I use the word total resistance, but in the parallel circuit I didn't use the word total, because total resistance means we have the formula 1 by R is equal to 1 by R1 plus R1 by R2. Here is not a total resistance, sum of the resistance, these two resistance 10 plus 2. So 10 plus 20 into, so we need to calculate the I2 current. So we need to multiply with the opposite branch. So opposite branch R1. So that's why 10. So into 10. Okay. So that's why we don't remember this current division rule, voltage division rule. So we can able to solve the problem easily. Okay, shall we have a break? Yes, sir, we have a break. After the break, we discuss. Okay?
Yes.
10 minutes.
The system they have calculated, right? In the system.
Yes.
There is also scientific.
Yes, here I will show that. Then next we have discussed the problems. I will show them.
I'm practicing manual.
Ah.
I thought totally not allowed. Calculator. I mean,
Okay, shall we start? Hello, sir, shall we start? Hello.
Yes.
Yeah, we can start.
Next, we discuss about the theorems. So here we discuss about the 4 theorems: Thevenin's, Norton, maximum power transfer theorem, and superposition theorems. We have 4 theorems. So usually the theorem which is used to convert the complex circuit into simple circuit. The complex circuit converted to simple circuit, then that's why we go for the theorem. Okay. And mainly these 2 theorems exclusively for the particular purposes. So see this linear circuit, it's a complex circuit. The complex circuit means it consists of n number of active components, n number of passive components. Assume that we take an amplifier. In our home, we have amplifier. In the amplifier, we have so many diodes, capacitor, resistance, so many things are there. So simply we say that entire square box. That square box we call it a amplifier. So many components are there. And finally, we take the two wire connected to the loudspeaker. The the loudspeaker we call it the load resistance. So that is here. The complex circuit having n number of resistors, all the things, the external is the load, only a loudspeaker. Okay. So the complex circuit, by using this theorem, the complex circuit is converted to simple circuit. So complex circuit converted to simple circuit. So what is the difference for the simple circuit? The simple circuit always having one active component, one passive component. So simple circuit having one active component, one active component, one passive component. So here for understanding, we take the passive component only resistance. For just for understanding, we say the resistance, because now we discuss about the DC fundamentals. So the passive component we say R. And what is the active component? We have 2 active components are there. One is a voltage source and is a current source. So that is voltage source is one active component, current source is another active component. So in your circuit, if you are using the voltage source, then it is called as a Thevenin theorem. If you are using the current source, then it is called as a Norton theorem. So the simple circuit consists of voltage source and resistance, then it is called as a Thevenin theorem. The simple circuit having current source and resistance, then it is called as a Norton theorem. Thevenin theorem, single voltage source and single resistance. And Norton theorem, single current source, single resistance. And another important thing, this single voltage source and single resistance are connected in series. In the Thevenin circuit, two are connected in series circuit. In the Norton circuit, 2 are connected in the parallel circuit. It is too important. Okay. And for DC circuit, we use the word RTH. R stands for resistance, TH stands for Thevenin's. And suppose the circuit is related to the AC circuit, means instead of resistance, we use the word impedance, Z. Let me discuss in the next class what is the definition for the Z. So right now, just remember RTH. In the other hand, we have a RN Norton resistance or ZN we call as a Norton impedance. So simply we say RN, RTH, RN. And how we get a simple circuit? By simplifying the complex circuit. The complex circuit having the put together, simply we say the internal resistance Rn. The internal resistance of the complex circuit we call as a RTH in the Thevenin resistance. We call as Rn in the Norton circuit. Or simply we say Rn which is equal to RTH which is equal to Rn. So here we use the word RTH, here we use the word Rn, here we use the word internal resistance. So from this what we say, RTH and RL are equal. Okay. Number 2. In our exam, still now they didn't ask this question, but at the same time we need to remember the tools. How to find the VTH? Still now they have no questions. How to find the VTH? In the complex circuit, we need to open circuit all the to find the VTH, to find the IN. So Thevenin circuit, we need to find the VTH. In the Norton circuit, we need to find the Norton current. To find the VTH or to find the Norton current. So in the complex circuit, we say n number of active components. The n number of active components, we may say n number of voltage sources or n number of current sources or combine those two things. So if you have your voltage source, we need to short circuit the voltage source. If you have your current source, we need to open the circuits. Open the current source. Okay. Just for information, in some of the problems, we may use these things. Let me discuss in detail about that part. So again, voltage source, short circuit, current source, open circuit. What is the meaning for the voltage source? Why we go for the short circuit means voltage source, we need to give the zero voltage. When we give a zero voltage, if we have a short circuit, we have a zero voltage. We have a zero current. When we get a zero current, by using the Ohm's law, I is equal to V by R. R is the infinite resistance, we get a zero current. When we get a zero resistance, that is, when we get an infinite resistance, we have an open circuit, we have infinite resistance. That's why the current source we become open circuit, voltage source we have short circuit. Again in detail, in the later topic we discuss. So similar concept, voltage, Thevenin theorem, Norton theorem, we may say, Thevenin theorem, we may say Norton circuit. Thevenin theorem, we may call as a so voltage source is nothing but a Thevenin theorem. And current source is nothing but a Norton theorem. So if we discuss about the theorem, we say Thevenin theorem, Norton theorem. If we come to the source, we say it's a voltage source, it's a current source. So in our exam, we have a question, convert the Thevenin theorem to Norton theorem. Or we may have a question, convert the voltage source to current source. So this type of questions may be asked in that exam. For example, here we say 10 voltage. Voltage, we say 5 ohm. So we have a voltage source, or we may say it's a Thevenin theorem. We need to convert the voltage source into current source. So we need to find the resistance. As I told, Thevenin theorem and Norton theorem, RTH and RL are same. So the value for R is 5 ohm. So here we use the word RTH, here we use the word RN. RTH and RL same, that's why we put a same 5 ohm. And we need to find the current. How to find the current? I is equal to V by R, so 10 by 5. So that means this is the five ohm and this is 2 amps. So the equivalent, this is a voltage source, equivalent current source is like this. So here important point we need to remember. See here, this is the plus symbol. So always current flow from the plus to minus. So that is the current direction is like this. So in the voltage source, the plus symbol we call as a starting. So similarly, the arrowhead we start the plus symbol. Suppose in your exam, here we have a 10 voltage, here 5 ohm. So here plus, here minus, here plus. Now we need to convert the voltage source into current source. So we put a symbol. This is RN, the value is 5 ohm. Now it's a current source. We need to put the arrow mark. See the arrow mark here, a plus symbol in the downward. So we put here like this. So answer is 2 ohm, 2 ampere. Okay. Sometimes in your exam, they may put like this. It is also correct because they put the arrow mark in the upward direction, the value is become minus symbol. So we need to carefully read the questions like this. So as I told, as you ask the question in your exam, we have a same question, slightly they change. The same question what we discussed right now. But in your exam, they change the plus and minus. But what we discussed in the classroom, we say 2 ampere. But we need to put the minus 2 ampere because they put the direction is changed. So by this way, they change the questions. We have, okay, first thing, just a minute, sir. So this is 2 ampere. So it is also right. Sometimes we may have it is also right. So here downward arrow mark, we put a 2 ampere. Here upward arrow mark, but we put a minus 2 ampere. So both are correct. So in your exam, read the questions carefully, read the options also carefully. Sometimes they change the terms. Next, we discussed about the maximum power transfer theorem. So the theorem is the next version of the Thevenin theorem. The Thevenin theorem, we complex circuit is converted to a simple circuit. Okay. In a simple circuit, we have 3 elements are there: VTH, RTH, and load resistance. So by using the maximum power transfer theorem, here the main important thing, we need to calculate the load resistance. That means we need to calculate the resistance value of the speaker. How to calculate the resistance of the speaker? By using the maximum power transfer theorem. So simple understanding, RTH, this is the condition. So RTH load resistance must equal to the internal resistance. Then the circuit gives the maximum power. So condition for the maximum power transfer theorem, which is equal to load resistance much is equal to the Thevenin resistance, or we may say Norton resistance, or we may say the internal resistance. So load resistance is equal to the internal resistance. Under these conditions, we are getting the maximum power. Now, for example, say here we say 10 voltage, and here the internal resistance of the circuit is RTH. Find the value of RL. What is the value? Because RL which is equal to RTH, so we have find by using the maximum power. And under this condition, we are getting the maximum power. Okay. Now, how much power? So now we forget about the theorem. So we have one voltage source, we have two resistance. Two resistance are contained in series circuit. Okay, correct? Correct? Okay. How much power consumed by this RTH? How we calculated? So we need to calculate the power. PTH. Power, what is the formula? V into I. V into I. Or we may say I square into R. Or we may say V square by R. Depends upon the basic available data. Suppose we take two resistance are connected in the series circuit. What is the total resistance value? 10 volt. What is the total voltage? 10. So what is the total current? 1 ampere. So here we have 1 ampere. What is the power consumed by that RTH? I square into R, 1 square into 5, we have 5 watts. Okay. What is the power consumed by this RL under the maximum power transfer condition? Here also 5. 5 watts. Because same current will flow because series circuit. The power consumed by the internal resistance is 5 watts. Power consumed by the load resistance is 5 watts. What is total power consumed by the circuit? 10 watts. So total power is 10 watts. How much power consumed by the load resistance? 5 watts. So 5 by 10 becomes 50%. So from this, what we understand, by using the circuit obeys the maximum power transfer theorem, the low resistance at the maximum, it's consumed 50% of the power. That question asked in that exam. At the maximum, we have only 50% of the power consumed by this low resistance, if it is obey the maximum power transfer theorem. Number 1. So number 1, we need to remember this point. 1. Number 2, 50%. Number 3, usually this theorem which is used in the communication circuits, mostly they are using the communication circuits. So communication circuit means it may be a receiver circuit or it may be a transmitter circuit, whatever things in general. Okay. And the fourth one, so we need to so here we need to calculate the IL. How to find the current flow through the low resistance? We need to find the IL. How to find the IL? I is equal to VL divided by RL by using the Ohm's law. Correct? By using the Ohm's law, VL by RL. Okay, by here. What is the total current? So here we have a RTH, here we have a RL. So here we say that IL, so I current will flow. Okay. How to find the I? I is equal to V by R. So VTH divided by 2 resistance are connected in the series. So we say RTH plus RL. Okay. This is the total current flow in the circuit. So these 2 resistance are connected in the series circuit. So the total current are same. So the small I, which is equal to VTH divided by RTH plus RL. Okay. It is for if the problem is related to Thevenin theorem. Okay. Suppose if the circuit obeys the maximum power transfer theorem, now if this equation becomes VTH divided by 2 RTH, correct? The pink color is exclusive for the Thevenin theorem. The red color is for maximum power transfer theorem because RL is equal to RTH. Okay. So this is the current. How to find the power? Power P is equal to I square R into RL. So I square into R. RL. RL is nothing but a RTH because it obeys the maximum power transfer theorem. So RTH. So by simplifying, we get this value. So sometimes this question also asked in that exam. So if the circuit obeys the maximum power transfer theorem, the maximum power PL which is equal to V square TH divided by 4 RTH. So sometimes they ask the current also. So it is a Thevenin equivalent circuit. So supply voltage is VTH, 2 resistance R. It is RTH. So how to find the IL? By using the Ohm's law. Sorry. So we need to find the IL. How to find the IL? I is equal to total voltage by total resistance. So VTH divided by RTH plus RL. So if you know the Ohm's law, we can able to solve this problem. Sometimes direct question, they ask this formula. And in the other hand, we have Norton current. So we need to find the IL. How to find the IL? So here we are apply the Kirchhoff's current law. What is the Kirchhoff's current law? Total current divided by total resistance. So total current, we say IN. So total current divided by sum of the resistance. We have two resistance are there, RN plus RL. And into opposite branch resistance. What is the opposite branch? RN. So RN. So if we know the Kirchhoff's current law, current division rule, we can be able to write the formula. That is instead of by got in the formula. So only know you need to remember the current division rule. Next is superposition theorem. So in exam point of view, when we apply the superposition theorem, these two questions frequently asked in that exam. In your circuit, if we have a multi sources, then Thevenin's theorem, Norton theorem, if we have a one sources or more than one sources, we can be able to apply. But the superposition theorem, if you have it in a complex circuit, if you have a more than one sources, is maybe a voltage source or current source or combination. So then only we can be able to apply the superposition theorem. So multiple source means default is a superposition theorem. Or if has independent sources, we can be able to apply the superposition theorem. So again, there is no need to go in detail about the independent sources and dependent sources. So in your college days, you studied these things. This type of symbol, we studied that. These symbols are referred the independent sources. So here in our exam, still now, we didn't have any questions related to the dependent sources. So that's why we forgot about the topic. Okay. So just remember these two terms. So the superposition theorem, we have one problem. Based on the problem, we understand the superposition theorems. Okay, now we discuss about some question answers. So all the questions, approximately 25 questions are there. So all the questions are asked in the exam. So here the questions related to the Ohm's law. So we have 4 diagrams are there. Which diagram obeys the Ohm's law? First thing, we need to check the x-axis and y-axis. So here all 4 options we have y-axis, the x-axis we have voltage. So here I we put a V. Okay. So that's why first thing we need to check that. Then we need to whether we ask about the voltage and current. So voltage current means it linearly increases. So out of 4 diagrams, these 2 diagrams are linearly increases. Both A and D are linearly increases. But from Ohm's law, voltage 0, current is 0. So see this A, voltage 0, we have some current. So these options are wrong. So we select this option. Here another question related to the resistance and current. So here they mention that source voltage is constant. So I is equal to V by R. We take V as a constant, which means I is equal to 1 by R. So we need to draw the graph for I is equal to 1 by R. So first we need to check the x-axis. So in independent variable resistance, all the 4 options we have R. In the y-axis we have a current. And Y is equal to 1 by X. So that is inversely proportional. So we need to take this one. And never note that never these 2 points is not touch the y-axis. Here is not touch the x-axis.
Yes, sir. The resistance of the value more than the voltage. In that case,
Whatever thing. Say here 100 voltage for 10 voltage. Here we have variable resistance. So we have another question. The previous problem is related to this one. So here we have a variable voltage. So here we have a current. So next we need to draw the graph voltage versus current. So voltage is variable quantity. So wherever voltage increases like this. So here we forget about it because it's a constant one. Even 0 voltage or 100 voltage or 1000 voltage, sorry, 1000 resistance value is always constant. So here we need to be here what we do in our laboratory, we adjust the rheostat and we see the variable resistance ammeter. That's all. The RPS, because you got just you go to the computer, the electronics lab, in the RPS, regulated power supply, we keep the voltage constant. And we are adjusting the rheostat only. So that's why we graph like this. So here we graph like this. That's all. Is maybe 10 voltage or 0.1 voltage, whatever thing. Or it's a 0 ohms or 10 1 mega ohm, whatever values. A wire of 2 meter length, and we have another wire. We have same material, same cross-sectional area. So they ask the question resistance. So we need to apply the formula. What is the formula? So far we are using the 3 formulas studied that. By using the Ohm's law, R is equal to V by I. This is the one formula. Another formula, R is equal to rho L by A. Another formula, RT is equal to R naught 1 plus alpha naught into T. These 3 formula, we discussed that. So which formula we need to use? Here the given data in terms of length, cross-sectional area, and same material. Material means is the resistivity. So we need to use this formula. R is equal to rho L by A. So from this formula, what we understand, resistance is directly proportional to resistivity. Here we have two wires having same material. So which means resistivity is constant. It is ruled out. Then area, cross-sectional area, both having same cross-sectional area. So is ruled out. The only thing, resistance is directly proportional to length. So length is high means resistance also high. So that means 5 meter wire having more resistance or higher resistance. That's all. So there is no need to do some mathematical calculations. So conductor have positive temperature coefficient and insulator having negative temperature coefficient. So best conductor, we have 4 different options are there. So how we say silver is the best conductor means in the data sheet, the silver having a, we have a, because we need to take the resistivity for the all the materials. Resistivity for silver, resistivity for copper. By this way, we take the 4 values. All the 4 values, we need to check that which is having a small number, that we call it a best conductor. So that's why we say silver is the best conductor. No. So here we need to remember that part. So why I say yes, because how we say this value means we need to check with the Google. We take the silver because in the explanations I need to put that explanations. So resistivity for silver, if you have that value and which is the least number, that is the best conductor. So I will put the resistivity values also there. Yes, just we need to remember that part in your exam. They didn't give the table, but we need to remember that part. So we have a silver is the best conductor, but usually we didn't use the silver in the bindings. We didn't use the silver in the overhead transmission line. We have different parameters involved that. And easy to understand. So I hope in your electronics lab, not the electrical and electronics, triple E students, triple E, we didn't have a list priority. If you go to the communication lab, you may have a pin diode, PIN diode one there. So usually the diode, the terminals is made of the silver because the silver is the best conductor. So that's by this way you can able to remember that silver is the best conductor. Mostly in the terminal part we use in the silvers. And I think one of the switch we have a mark in the market, the advertisement, one of the switch, the terminal, they use the silver coated. The silver coated because they have a good conductivity. They have 2 reasons are there. One is the best conductor, another is avoiding the oxidation. So we have 2 reasons are there, but it's one of the reasons. Yes, sir, tell me, sir. Best conductor is a second is a copper. Then I will give the details in the next class. So here we have a best conductor only. They ask that. At the same time, I will put the slides. That's why we can able to understand. Okay. I understand that. I will keep that. But for the kind of information, more than 2.5 years or 3 years, the same question asked in that exam. Yes, correct. But mostly they didn't ask the second best, which is the best one. Because again, most of the questions they ask the real-time applications. In the construction activity, most of the questions we may correlate with the construction activities or daily life or related to the QCS 2014. So 100 resistance, each resistance having 100 ohms. So here it's a series circuit. So the formula is N into R. So that's why we use the word 100 into 100. And in the other hand, we have a parallel circuit. The formula is R by N. So 100 by N. So 100 by 100, we have 1 ohm. So here we have a n resistance. Each resistance having R ohm. So see here R1, R2, R3, Rn. We have n resistance are there. All the n resistance are connected in parallel. So that's why all the resistance are connected in the parallel. And each resistance having R ohm. So it is R ohm, it is R ohm. All the resistance having R ohm. Equal. Equal resistance. So you take the first line or connected in the parallel, then the resultant resistance. Resultant is nothing but a total resistance. So what the formula? RT is equal to R divided by N. This is, so here what is the RT? Total resistance is X. The R stands for value of the resistance. Here small letter R. And N stands for number of resistance. Here we have N resistance. So from the first line, we are derived this line. X is equal to R by N. Now we go to the second line. When this N resistance, which means the same R ohm resistance, are connected in the series circuit. So that is RT. So to avoid the confusions, I use the word RT series. So here RT parallel is equal to R into N, which is equal to N. What is the value of R? Okay. So RT series is equal to N into R. Now from here X, here Rn. So we may equating small letter R is equal to X into N. So we substitute here. So we get this value. So one by one you may see that. So the here small letter R, X is equal to R by N. So that's why R is equal to N into X. So this X, this one. This R, this one. So that's why we are getting this equation. Then we have a series circuit. So N into X. Okay. RT series, which is equal to, formula is N into R. N into R. This is the formula. So N, we put N. The value for R we derived from here. So that's why N into Nx. So N square into X. Okay. So here for this formula, here only thing we need to remember this formula. R by N and N into R. If you know these two formula and simple logic, we can be able to get the answer. We have three resistance, 2, 3, 6. Which of the following combination give the effective 4 ohm resistance? So 2, 3, 6. So usually what we do, first we take the option A which is equal to 3 resistance are parallel. So that means 1 by R is equal to 1 by 2 plus 1 by 3 plus 1 by 6. By using the formula, we need to take the value. That value which is equal to 4 means option A is right. So we need to do the mathematical calculations. To avoid the mathematical calculations, what we say, in the parallel circuit, the total resistance value always less than the least resistance. Here 2, 3, 6, which is the smallest number, 2. So if all the resistance are connected in the parallel means the resistance value less than 2 ohm. That you don't need to do the calculator. So the value must be less than 2 ohm, which is not equal to 4. So that's why A is wrong. Similarly, you go to the option D. So here it is greater than 6 ohm, which is not equal to 4 ohm. So that's why option D is also wrong, because the series circuit total resistance value always greater than the greatest resistance. So that's why without doing the mathematical calculations, the A and D are ruled out. Only thing we have 2 options. So now we do the calculations. 3 ohm resistor in series with the parallel combination. That means like this. 2 and 6. So this is the circuit diagram for the C. So 2 and 6 are connected in parallel. What is the formula? 2 into 6 divided by 2 plus 6. What is the value? 18 by, sorry, 12 by 8. This combination is connected series with the 3 ohm. So what is the formula for the series circuit? Add. So B3 plus. So 3 plus 1.5, 12 by 8 become 1.5, which is equal to, not equal to 4. That's why option C is also wrong. So which means we may select default, we may select the option B. At the same time, due to the curiosity, because we need to spend another few seconds, thereby we need to confirm our answers. So 2 plus 3 into 6 divided by 3 plus 6. Because we are familiar with that drawing. So without draw the diagram, we can able to write the equation. So 2 plus 18 by 9. So is equal to 4. Okay. So heat is produced in a current carrying wire in 5 seconds is 60 joules. The same current is passing to the another wire, but the another wire having a resistance is half of the aerial one. Another wire of the half the resistance, because earlier current carrying wire, say R ohm, means it's R by 2 ohm, R by 2 resistance. Okay. So heat produced in the 5 seconds will be. So before that, heat, you take the resistance, the current is passing to the, they are applying the voltage, what will happen? The circuit is closed, current is flowing. The current flowing to the resistance, what will happen? We are getting the heat energy. Simple example, iron box. So the electrical energy is converted to the heat energy. So that's why heat energy is directly proportional to current, the electrical energy. So electrical energy, which is equal to power into time taken, is directly proportional to power into time. Is directly proportional. What is the formula for the power? I V into Y, I square into R, V square by R. Here I use the word I square R because the given data in terms of current and resistance. That's why I use the word, I use this formula. So heat is directly proportional to current square, resistance, time taken. So here they use the term same time taken. Same time taken. So the current is directly proportional, it's same. So it's a constant, you leave it. And same current is passing. Same current is passing. So it is also ruled out. So heat is directly proportional to resistance under this condition. So now first wire have 60 joules. For the second wire, half of the value, because they use the word half the resistance. So this resistance having 60 joules means this resistance having half of this value, so 30 joules. So simply we may, this is the conventional method, but by using this concept, we can able to get the value immediately. So only thing, just we need to write the equation. Then only we can able to get the idea. We have three resistance, each of 1 ohm. How many different combinations we need to do? We have three resistance. We need to connect the different connections, but we need to mandatory use all the three resistance. So that is the constraints, because they use the word all the resistance must be connected in the circuit. So that's why we need to connect the 4 different combinations. All the resistance are series circuit, all the resistance are parallel circuit, or these combinations. So each combination having different resistance value. So that's why the default, the answer is 4. And you may have one doubt, suppose in your exam, instead of the 3 resistance, suppose they ask the 4 resistance, what is the answer? So this, they never ask these questions because we have used the formula NCR. So in the mathematics, we study the formula, not NCR, because we are working in the construction activity. So that's why we may confuse that word. Commutation, permutation, in the mathematics, we studied that. So by using these commutation permutations, we may calculate it, but in our exam, they never ask that. So we forgot about that part. So in our exam, they ask only 3 resistance only. And another important thing, they ask always same resistance value. If we have a 3 resistance, different resistance value means we have a different combinations also that. So the question is constant one, same question. Only thing they may ask instead of 1 ohm, they use the word 5 ohm. Even though it's a 5 ohm also, we have 4 combinations only. So in our exam, we have a question related to the units. So I observed that so far these 4 questions asked in that exam, especially units. So conductance, mho, or we may use the word Siemens, resistivity, ohm meter, and current as an ampere. And this is we discussed in the AC circuits or in the transformers. So anyhow, right now, flux density is the unit for the Weber per meter square, or we use the word Tesla. So here, mho, or we use the word Siemens. No. R is equal to rho L by A. So that is rho is equal to R A divided by L. R ohm, area meter square, length meter. So meter cancel, ohm meter. Conductivity. So the reciprocal. So the ohm becomes mho meter divided by the reciprocal. That's right. Actually, we need to put like this. Rho is equal to ohm meter. Sigma is equal to 1 by rho, which is equal to 1 by ohm meter, which is equal to 1 by ohm, 1 by meter. 1 by ohm we call as a mho by meter. That's all. Okay. So we have a resistance and we have a voltage source. It's a variable voltage source. So I hope in your colleges 5 years or 10 years or 15 years back, we assume that it's a RPS, regulator power supply. So 0 to 30 voltage. And here we are using one resistance. So in our electronics lab or electrical lab, we have so many resistance are there. We take a very thin resistance, which means the resistance value we say half watts or quarter watts. So very thin means quarter 1 by 4 watts. Little bit means we say that 1 watt. So we take one resistance value. Say 1 by 2 watts resistance. Assume that. Okay. Now we are connecting the circuit. So the closed circuit, we are increasing the volt because it's connected to the RPS. by increasing the voltage, what will happen? Current is increasing. The current is increasing, what will happen? The current flow to the resistance also increasing, which means the current flow in the resistance will happen is produce the heat energy. Again, we are increasing the voltage. What will happen? The more current is increased. We are increasing the more current. So that will, thereby the heat is increases. One fine time, what will happen? Is the breakdown. Okay. One fine time, if you increase in the voltage, the resistance, you get a more heat energy, thereby it becomes burst or it becomes a open circuit. Okay. So similarly, it may happen in the classroom. So it's a right time 9:30. So today we close the class right now. Again, if you continue that, it may be broke down and the first class, you never come to the next class. So that's why we stop today's class right now. We discuss the rest of the topic in the next class. Okay? Sir, okay? Hello?
Yeah, okay, thank you.
Okay, thank you. We see in the next class. Next class coming Wednesday. Okay? Thank you.
There is no test, right?
Yes, in the mock exams.
Most of the
So here, so I have 16 questions are there. Just a minute, 1 minute.